In the previous lecture, we have talked about the Jacobi's method. In this lecture, we are discussing about the Cauchy problem that deals with the finding the integral surface passing through given curve. Let us discuss the problem of quasi-linear equation, quasi-linear partial differential equation, and then we will talk about the non-linear partial differential equation. So here we will obtain a required integral surface from the general integral. So for that, I am considering f of u v equal to 0 and v equal to g of v be the general integral of partial differential equation, that is p into small p, q into small q is equal to r, where this value of p that we know it is del z by del x and q is del z by del y, where this f is an arbitrary constant, or I can say arbitrary function of u and v. If you use the g, then g is an arbitrary function of u, where this u of xyz equal to constant and v of xyz equal to constant, let's say c2, are the solution of equation dx upon p equal to py upon q equal to dz upon r. So these are the auxiliary equations we have, and that is we have did in the quasi-linear equation to find out the solution of this type of equation, that is capital P into small p plus q into small q is equal to r. This is the auxiliary equations are there, and to get this solution for this is written in the form of f of uv, where u and v are can be obtained from this auxiliary equations. Now let us see, is the given curve, let C be the given curve whose parametric equation are given by x is equal to x0s, y equal to y0s, and z is equal to z0s, where s is a parameter not necessarily the arc length of the fixed point, that is not necessary with the arc length from a fixed point. Now we want to find out a particular function f, that is this function f we need to find out. That means the surface we need to find out containing this given curve. So we have given this curve before the problem is starting, and we need to find out the surface which passing through this curve. That is our objective. So what we will to do is we want to find a particular f such that the surface FUV equal to 0 contains the given curve C. And this is done as follows. How to do this one? Consider the equation u of xyz equal to constant and v of xyz equal to constant. Substitute this value of x is equal to x0s, y equal to y0s, and z is equal to z0s in this equations. And we get, if I substitute here in place of x, x0, in place of y, y0, in place of z, z0, and everything is converted into the s. So we'll have x0s, u of x0s, y0s, z0s equal to c1, and v of x0s, y0s, z0s is equal to c2. So we'll have this, and we need to eliminate this s between them. And we get a relation between C1 and C2. Let the relation between them to be given by f of C1, C2 equal to 0. Then f of uv is equal to 0, and this is a required solution as f of uv equal to 0 into the integral surface. Moreover, the initial line, whatever the curve it is given to us, that is this, that curve is lies on this surface which we have obtained it at last. For that, f of u of x0s, y0s, z0s, v of x0s, y0s, z0s is equal to f of c1, c2 equal to 0. And sometimes instead of f, we can also use the definition v equal to g of u. That also can be used. So sometimes the solution can also be obtained by assuming v equal to g of u and determining g. Suppose we assume the form of the integral of this form v equal to g of u, then since the given curve is lies on the surface, we have x is equal to x0, y equal to y0, z is equal to 0. In the relation v equal to, we have to substitute that. We'll have a g is equal to g of s is the relation we got, and same we'll see by the example also. So let us have this example. Question is, find the integral surface of the curve or equation 2xy minus 1 into p plus z minus 2x square into q equal to 2x minus yz, which passes through the curve or the line, which passes through the line x0s is equal to 1, y0s is equal to 0, and s0s is equal to s. So first of all, you should note that this is the quasi-linear equation. So the auxiliary equation R, that is dx upon p equal to dy upon q equal to dz upon r, where the value of p is this one, that is 2x minus 1, q is z minus 2x square, and r will be this. So that's why this will gives me dx upon 2xy minus 1 equal to dy upon z minus 2x square equal to dz upon 2x minus yz. That you can just see that this three value we have here. Now we need to find out what would be the solution for this. So to do this, you just observe something here. If I can multiply this equation by z, then this will be 2xy. If I multiply this is by x, then here is also 2xy there. That will be cancelled out. And if I add this value with this, so what I will do is I just do this. That is z dx plus dy plus x dz. In the denominator, what we will have, it is 2xy z minus z plus z minus 2x square is there, plus if I multiply this is by x, then we will have it as, you will have here it is 2x square minus 2xyz. So this 2xyz is get cancelled out, this is cancel out, this is also cancelled. So that is, I can say, so therefore z dz plus x dz plus dy equal to 0. So if I take the integration, this is nothing but the z as it is derivative of x, x as it is derivative of y. So it is xz plus y equal to constant c1. Now to get the another solution, that means I need to find out another one. This is will get the first one. To get the another one, you just multiply this equation by x, the first equation by x. So what we'll have, it is x dx plus y dy. Let me see what is this. So if I multiply by the x, this is 2x square y minus x. 2x square y minus, so sorry, I have multiplied with x here. And if I multiply this is by y, this is plus z y minus 2x square y, 2x square y. This will get cancelled out. So we'll have this is equal to x dx plus y dy upon minus of x plus zy. And that is, this will be plus here, plus. So if I take minus common from this, then we will have it as yz minus x. That is equal to dz upon, you just see that 2 times yz minus x is already there. X minus yz is here. So it is 2 times x minus yz. This will get cancelled and you will have minus sign here. So this will gives me 2x into dx plus 2y into dy minus dz equal to 0, but that minus will become, here it is plus. And if I take the integration, both sides will gives me x square by 2, 2 will get cancelled, y square by 2 is also get cancelled, and here you will have z plus z equal to some constant c2. So now the general integral we can write down. Therefore, the general integral can be written as x square plus y square plus z is equal to, that is this, equal to g of y plus xz, where g is arbitrary function. Now, what is the question? The question is to calculate or find the integral surface passing through this curve. That means ultimately I need to find out the curve which is passed through this situation. That means you need to substitute the value x0 is equal to 1, y0 is 0, and z0 is equal to s into this equation. So putting x is equal to x0, s equal to 1, y equal to y0, s is equal to 0, and z of s0, z is equal to z0 of s is equal to s. We get 1 plus 0 plus s is equal to g of 0 plus s. So that means g of s is nothing but the s plus 1. So this is my function. This g function is this much. So therefore, the required integral surface, the required integral surface is x square plus y square plus z is equal to g of y plus xz is there. But what is g of s? G of s, according to that, it is s plus 1. So that is, this is s. So it will be y plus xz plus 1. In place of s, we have this quantity. So this is s here, s plus 1. So the final answer is x square plus y square minus xz minus y minus z minus 1 equal to 0 is the required integral surface which we are looking for. Let us solve one more example. So example is saying this: find the integral surface of the equation x cube p plus y into 3x square plus y cube is equal to z into 2x square plus y, which passes through the curve x0 equal to 1, y0 is equal to s, z0 is equal to s into 1 plus s. So this is also a quasi-linear equation that you can see. So the auxiliary equation we can write down dx upon p is equal to dy upon q equal to dz upon r, where the value of p is, we know it is x cube, value of q is this, and value of r is this much. So that means we have dx upon x cube dy upon y into 3x square plus y, and that is equal to dz upon z into 2x square plus y. Now just observe something here. That is 3x square is here, 2x square will be here, x square is there if I go. So if I can do this one now, 1 upon x dx plus 1 upon y dy plus 1 upon z dz. What will we get? It is x square. So I need to cancel out something. So that's I take minus here and the minus sign also here. So this is minus x square. This will be a plus sign, that is 3x square plus y, and the minus sign is here, minus 2x square minus y. So just check that this 2x square and this 3x square will get cancelled. Y is also get cancelled. So that is equal to, you get minus 1 upon x dx plus 1 upon y dy minus 1 upon z dz is equal to 0. So hence this will give me, if I take the integration both sides, this will gives me minus ln x plus ln y minus ln z is equal to ln constant c1. So hence this will give me y upon x z equal to constant. Now other to do this one, inspiration from the what you can observe this too, that is x dx upon this dy upon this, that will lead to 3x square plus y dx by x cube dy by dx. So let's see this. Now we can do this. Dx upon x cube is equal to dy upon y 3x square plus y. So this will implies 3x square plus y dx upon x cube is equal to dy upon y. And if I take the addition of these two, it is 3x square plus y dx plus dy upon x cube plus y. So 3x square we don't have any problem. If I take the difference integration of 3x square, we don't have a problem. Dy independently no problem. So it is y dx is there. So I need to add x dy here to do this next calculation, because this is equal to dy by dx is already there. We have used the, so that is equal to dy by dx is there. So multiply x here and add it here, so that we can integrate this quantity. What I'll do is 3x square plus y dx plus dy is already there. I'm adding x dy. In the denominator we have x cube y plus x dy, so it is xy is there, is equal to dy by y. This is the quantity we have. So you just see this integration of this one, this quantity. So that is 3x square dx plus dy plus y dx plus x dy upon x cube plus y plus xy is equal to dy by y. Now the derivative of x cube is 3x square. So I can just write down the numerator is d of x cube plus y plus xy upon x cube plus y plus xy is equal to dy by y. Now if I take the integration both sides, because you can just see that the derivative of 3x square is 3, x cube is 3x square. The derivative of y is dy and the derivative of xy is y as it is dx, x as it is dy. So that we have. If I take the integration both sides, this will lead to ln of x cube plus y plus xy is equal to ln of y plus ln of c2. So final answer is x cube plus y plus xy upon y is equal to c2. So we have now two equations. This is the second one and this one is first one. We need to obtain the solution of this PDE passing through this curve. So for that I need to substitute this value of x0, y0 and z0 into this equations. So on substituting, x is equal to x0 equal to 1, y equal to y of s0 is equal to s, and z is equal to z0 of s is equal to s into 1 plus s in u equal to c1 and v equal to c2. We get, what will we get? What is, this is our v and this one we have, it is u. So if I substitute this value where s is, y is s, so it is s upon 1 into s into 1 plus s. So what we have, it is, the equation is y upon xz is equal to c1. So that will implies y is s upon 1 into s into 1 plus s is equal to c1. So that gives me 1 upon 1 plus s is equal to c1. That is the value of first one, c1. Second, this equation we have to substitute this value. Next, the second equation is x cube plus y plus xy upon y equal to c2. If I substitute this value, that is x is equal to 1, s plus 1 into s, again s upon s is equal to c2. So that will give me 1 plus 2s upon s is equal to c2. Now we need to eliminate s between these two equations. That is this equation 3 and from 4. So using 3 and 4, we need to eliminate s from this. And I have the equation only in terms of c1 and c2. So what is that equation we have? Here we have 1 plus 2s is equal to c2, and previously we have 1 equal to c1 into 1 plus s into s is here. So from this we can calculate what will be the value of s, and from this we can calculate what is the value of s. So from that we can get 1 is equal to c1 plus c1s. So it is c1s is equal to 1 minus c1. So s is equal to 1 minus c1 upon c1. And here we'll have 1 equal to s into c2 minus 2. So s will be 1 upon c2 minus 2. And both this s values are equal. So therefore we'll have 1 minus c1 upon c1 is equal to 1 upon c2 upon c2 minus 2. Simplify this one, we'll have 1 minus c1 into c2 minus 2 is equal to c1. So that will gives me C2 minus 2 minus C1 C2 plus 2 C1 equal to C1. So that will leads to C1 C2. If I take this everything on the other side, minus C2 minus C1 plus 2 equal to 0. So hence we have f of C1 C2 equal to this C1 C2 minus C2 minus C1 plus 2 equal to 0. And if you substitute this value of C1 and C2, that is in terms of U and V, therefore f of UV equal to 0 implies that as per this function, this is the function f C1 C2. So it is U into V minus U minus V plus 2. So U into V minus U minus V plus 2 equal to 0. But what is the value of U we have obtained? We have obtained y upon xz. And what is the value of V we have got? It is 3 minus y plus xy upon y. Minus U, it is y upon xz. Minus x cube plus y plus xy upon y. Plus 2 equal to 0. Now we need to simplify this. So this will get cancelled. And we'll take the LCM as xyz. So y is multiplied here. So it is y into x cube plus y plus xy minus y square minus z into x cube plus y plus xy plus 2xyz equal to 0. And further, if you simplify this, you will have x cube y plus y square plus xy square minus y square minus z x cube minus yz minus xyz plus 2xyz equal to 0. So just see, something is cancelled out, y square will get cancelled. So finally left with x cube y xy square plus xyz and this term. So that is the terms we can have here, and that is your final answer that we have. So this is your final required surface we got. So these are the two examples which we have solved to obtain if a quasi-linear equation is given, and if you are given one surface, one curve, and passing through that curve, we need to calculate the integral surface. And ultimately, it is known as a Cauchy problem. Now, we'll discuss for non-linear PDE. So for non-linear PDE, we have learned two methods to solve that. The first one is Charpit's method, another one is Jacobi's method. And the problem is here is also same. We need to obtain the solution of the complete integral with the passing through given curve. That is our objective. So we will obtain the solution of the form a complete integral f of xyz ab equal to 0 be a complete integral of f of xyz pq equal to 0. We are interested to finding the solution of this equation. Let me say this is the equation number 1 and this will be 2. So we are interested to find out the solution of this equation passing through given curve. We are interested in finding a solution of equation 1 which passing through the curve c is equal to x is equal to x0s, y equal to y0s, and z is equal to z0s, where s being a parameter. So we expect that the solution to be an envelope of one parameter subfamily of the equation 1. Let E be the envelope containing this curve C and S be the subfamily of that. So C is the curve. We'll consider E is an envelope which contains the curve C and S is the subfamily. If E, the envelope of the subfamily, will touch each other, each member of the subfamily, as C is lies entirely on its E, it will touch each family of S, and which required that this f of the whatever the solution we have, x0 of S, y0 of S, z0 of S, AB equal to 0, be satisfied for each A, B and belong to the corresponding subfamily for S. Let us solve an example and see how this will work. Okay. So we have this example. Find a complete integral of the equation p square plus q square x is equal to pz, and the integral surface containing the curve c is equal to x0 is equal to s, y0 is equal to s square, and z0 is equal to 2s. So this is the nonlinear differential equation is given to us. And from nonlinear differential equation, either you can use Sharpit method or Jacobi's method to solve that. Once you obtain the solution, we are required to find out the solution passing through this curve. So the auxiliary equation are using the Sharpit's method. We know it is dx upon fp, dy upon fq, dz upon pfp plus qfq, dp upon fx plus pfz minus dq upon fy plus qfz. So if I use this one and calculate fp, that is the derivative of this with respect to p, will leads to dx upon 2p's x because that is the derivative, minus z is equal to dy upon derivative of this with respect to q will gives me 2qx is equal to dz upon p dx. That means to multiply this by p, so it is p square x minus pz plus 2q square x is equal to dp, that is fx, that is p square plus q square, p square plus q square minus p into fz. Fz is minus p, so it is minus p square is equal to dq upon fy, which is 0 because there is no y here, plus q fz, that is minus pq. This will be minus pq, but here it is minus, here it is minus, already we have. So this will get cancelled out. So we have it is minus dp upon q square. Here we'll have it is minus dq upon minus pq. So if you can just rearrange this one q is get cancelled out. This minus sign will get cancelled. So we'll have it is p dp plus q dq equal to 0 will leads to p square plus q square is equal to some constant a square. Ultimate goal is to obtain the value of p and q in terms of x, y, z, and then substitute it in the Pfaffen equation. P square plus q square is a square, and given equation is given in this form, p square plus q square into x pz. So that will gives me the value of p. So now given equation is p square plus q square into x is equal to pz. This will implies a square x is equal to pz. That will implies p is equal to a square x upon z. So that will gives me p square plus q square is equal to a square, will gives me q square is equal to a square minus p square, will gives a square into a square minus x square a raised to 4 upon z raised square. If you take common out a, and if you take the square root, then it is plus or minus a into square root of z square minus a square x square upon z even. Now the Pfaffen equation, that is dz is equal to p dx plus q dy. P is this value x square a square x upon z dz plus q, that is plus or minus a into z square minus a square x square upon z dy. You just see that z is a common out and you can take as LCM. So it is z into dz equal to a square x dx plus or minus a z square minus a square x square dy. And you just see that it is adjusted by the square root. So I'm dividing this square root both sides and taking this quantity on the other side. So it's z dz minus a square x dx upon square root of z square minus a square x square is equal to plus or minus dy, a dy. And just see that the derivative of z square is here, z dz. So it just multiply by 2 and divide by 2. And taking the integration both sides. So if I take the integration, so on integrating, we obtain the denominator's derivative is in the numerator. So we'll have 1 by 2 z square minus a square x square that we have raised to minus 1 by 2 plus 1 upon minus 1 by 2 plus 1 is equal to, on the other side we have it is a plus or minus y. This 1 by 2 will get cancelled with this, and plus b is already there. So if I take the square both side now, will gives me z square equal to a square x square plus ay plus b whole square. Now what is the things is given is, this is our complete integral. So the complete integral is for, this is a complete integral for given PDE. But the objective was given is to find out the integral surface containing this curve. So we need to substitute this value into this given surface we have obtained it here. So putting x is equal to x0 of s is equal to 0, this is given. Y is equal to y0 of s is equal to s square, and z is equal to z0 of s is equal to 2s. We get, so we substitute x is equal to 0 here. The equation is z square is equal to a square x square plus ay plus b whole square. We substitute 2s, so it is 4s square equal to 0 plus a s square plus b whole square. Now to eliminate or to obtain a relation between, we need to eliminate s from two equations. The first one is this, another one is, so this is of the form, I can say capital F of x0, y0, s0, z0 and ab. This is the first equation. The second equation is this, del f by del s equal to 0. We need to differentiate this equation with respect to s. So differentiating above equation with respect to s, we get. So what we will get here, it is 8s is equal to 2as square plus b into derivative of this, that is 2as. So it will gives me 2s is equal to as square plus b. S is also cancel out. So actually it will have 2 equal to a into as square plus b. Now if I can call this is as equation number 1, if I can say this is equation 2 and this will be equation 3. Now on eliminating, what we need to eliminate the value of s. Eliminating s between the equation 1 and 2. We obtain. So need to eliminate s from 1 and 2. So you just observe that from this we can get the value of s square. So that value is 2 by a equal to as square plus b. So that will implies as square is equal to 2 by a minus b. So that will imply s square is equal to 1 upon a 2 by a minus b. And if you substitute this value into the equation number 1 that we have here, So that will leads to the equation 1 is this 4s square equal to as square plus b whole square. So 4 into, you just substitute this value 1 upon a 2 by a minus b equal to a 1 upon a 2 by a minus b plus b square. So it is 4 by a 2 by a minus b equal to, this a will get cancelled. So inside we'll have 2 by a minus b plus b whole square. This b is also get cancelled. So finally it is 4 by a 2 by a minus b is equal to 4 upon a square. 4 will get cancelled, a will get cancelled. So we'll have it is 2 by a minus b equal to 1 upon a. So that is 1 upon a minus this 2 by a will gives me 1 upon a equal to b. So that will gives me ab equal to 1. So we have one equation that is ab equal to 1. So that will gives me b equal to 1 upon a ultimately. So the one parameter family of the curve, the one parameter family of the complete integral is z square equal to. So what was our equation number 1? Is this. What I have written is 1, 2 and 3 here. So the equation number 1 is this one. Here we have to substitute b equal to 1 upon a, which we got. So therefore we have the one parameter formula is z square equal to a square x square plus ay plus 1 upon a whole square. Simplify this one by taking LCM. What we get? It is a square z square equal to a power 4 x square plus a square y plus 1 whole square. And further we need to eliminate a from this one. Okay, so this is a one parameter family we got, and I want a surface which is passing through that curve. Okay, so to obtain this one, that one we need to eliminate a from this. To eliminate a, we need to again differentiate with respect to a. Okay, so differentiating. So for that I need to simplify further this one. So that is a square z square equal to a power 4 x square plus a power 4 y plus 2 a square y plus 1. So I just have square up this. So a power 4 is common from this two. So we'll have a power 4 x square plus y square plus a square will be common out from this two. So it is a square into 2y minus z square plus 1 equal to 0. We'll differentiate this with respect to a square. So on differentiating, with respect to A, we get 4a cube into x square plus y square plus 2a square 2y minus z square equal to 0. 2a is common out and cancel because on this side it is 0. So it will have 2a square x square plus y square plus 2y minus z square equal to 0. So that will leads to the value of a square will be 2a square will be 2y minus z square upon x square plus y square. So this will be the value of a square. And if you substitute this value of a square into this equation, that is equation number, whatever the number we have, the equation number is 4. Putting this value in 4, putting value of a square in equation 4, we get what we will get. You just see that. What is equation 4? Let me write first. That is a power 4 x square plus y square plus a square 2a minus z square plus 1 equal to 0. So a power 4, we have the value of a is this. So it is 2y minus z square upon 4 x square plus y square square into x square plus y square plus 2y minus z square upon x square plus y square into 2y minus z square plus 1 equal to 0. You just observe that this 1 x square is cancelled out, x square plus y square. And if you take the LCM as x square plus y square, this will be, here we have 2 because that 2 is already there. So we can have 2y minus z square square. 4 is also take LCM. 4 is also LCM. So this is 2y z square whole square is there. Plus here what is left? It is plus 2 into 2y minus z square whole square plus 4 times x square plus y square will be there equal to 0. So finally, what we got, so this is minus, huh? So here you will have minus sign. So this is have a minus sign. So finally what we got, it is 4x square plus y square equal to 2y minus z square whole square. That is exactly the quantity we have here. And that means the z square, the value of z square minus z square plus 2y is equal to square root of 4x square plus y square. And that will give me z square equal to plus or minus 2 is common, y plus or minus under root of x square plus y square. And that is our required surface, which does not have any arbitrary constant. And if you want, you just discard the minus sign from this. Due to x square plus y square is greater than y, greater than or equal to y. So the required surface is 2 into y plus square root of x square plus y square, which is the required integral surface passing through given curve. So the procedure is, first we can get the complete integral, then we need to try to eliminate one of the arbitrary constant and then another arbitrary constant, and that leads to the complete integral. Let me solve one more example with the same method. So question is, find the complete integral of the equation p square x plus qy minus z is equal to 0 and derive the equation of the integral surface containing the line y equal to 1, x plus z equal to 0. So here why it is a line? Because this is a plane and this is also a plane. Intersection of these two planes is a line. And this is a non-linear equation is given. So either you can use the Charpit's method or a Jacobi's method to solve this. I'm using the Charpit's method to do this. So I'm not writing now the auxiliary equation in detail. So you know already a formula for auxiliary equations. Okay, so that is dx upon fp. Fp is the derivative of this with respect to p. So that will be gives me 2px is equal to dy upon fq, that is y, is equal to dz upon pfp, that is 2p square x plus qy is equal to dp minus dp fx, that is p square plus p into fz, that is minus 1. So that is minus 1 is equal to minus dq upon fy, that is q, plus q into minus 1, fz, that is fz is minus 1. So you will have dq upon 0 here because it is q plus minus q is there. So dq is 0, so that means q is constant. So that will give you dq is equal to 0 and that will implies q is constant, let's say a. Given that the equation is p square x plus qy minus z is equal to 0, q is constant, so that will give me p square x plus ay minus z is equal to 0. So that will give me p square will be plus or minus z minus ay upon x whole raised to 1 by 2. So on substituting this value into the Papian equation, so now we have dz is equal to p dx plus q dy. The value of p we have obtained it, that is plus or minus z minus a y upon x raised to 1 by 2 dx plus q, that is a dy. Now you just multiply by this quantity both sides. Divide by this z minus ay both side, and this ay you can take on the other side. So we'll have dz minus a dy upon square root of z minus ay equal to plus or minus 1 by x dx, square root of that. You know that the derivative of this quantity is in the denominator. So that is z minus ay raised to 1 by 2 is equal to plus or minus x raised to 1 by 2 plus some another constant b raised to 1 by 2. So finally, what we get if I take the square both sides, and we get the value is, so I don't want the square root because when I take the differentiation of this, again we'll have a problem. So I want to remove this square root thing from this. So for that, what we can do, we'll take square is ay minus z. Okay, so we'll have z minus ay. We are taking the square both sides. So we'll have z minus ay is equal to plus or minus x raised to 1 by 2 plus y raised to 1 by 2 square. So we'll have a square of this one will gives me x. X plus b plus 2 times x into b plus or minus square root. This two quantity I am taking on other side, that is minus z minus ay minus x minus b equal to plus or minus 2 times square root of x square root of b. Take the square both sides. We'll have z minus ay minus x minus b whole square equal to 4 times x into b. This plus or minus gone now. So this is as a complete integral. This is a complete integral. Now our objective is to eliminate this a and b from this one by putting the value that is a given curve. So parametric curve or the curve is given in this form, in the Cartesian form it is given. A given curve is y equal to 1 and x plus z is equal to 0. So I am putting x is equal to s. So z will be minus s because x plus y is ultimately 0 and y is 1. Putting this value in equation 1, we get, you just see that what will we get? That is z, I have to substitute as s. So it is s, y as 1. Let me write this equation here. Z minus ay plus x plus b square is equal to 4bx. We have to substitute this value. So that will z is minus s. Ay, that is a. X is s. B square is equal to 4bx is s. So this s will get cancelled. So we'll have b minus a whole square is equal to 4bs. So the value of s we get from this is all the terms are minus. So I have written plus here. This is minus and this is also minus. Yeah, everything is minus here. So this is also minus, and this is minus. So this is not cancelled. This will be S. So finally, we will have here SS. So if I take minus common, so that is 2S plus A plus B whole square is equal to 4DS. Now we have to eliminate S from this one and its differentiation. So taking on differentiating, something goes wrong. Oh. Wait a minute, I think so something goes wrong in the yeah. So what we got here on differentiating with respect to S, this quantity. What we have it is 2 times 2S plus A plus B. The derivative of 2S with respect to S will gives me 2 is equal to, on the other side, it is 4BS. B. 4 will get cancelled. So from this we get the value of S. That will be 2S plus A plus B is equal to B. B will get cancelled. It gives me 2S plus A equal to 0. So that will gives me S is equal to minus A by 2. And if I substitute this value S in 1, sorry, in this 2, so value of S in equation 2, putting S is equal to minus A by 2 in 2, we get the equation 2 is this 4A plus B plus 2S is equal to 4B. No, not this one. The equation 2 is A plus B plus 2s whole square is equal to 4bs. Here we have to substitute minus a by 2 instead of s. So it is a plus b minus 2 into a by 2 square is equal to 4b minus a by 2. This 2 is cancelled out and a is also cancelled. So we'll have b square is equal to 4 will cancel with the 2 now. So it is 2 into minus ab. So we'll have b square plus 2ab equal to 0. If I take b common, we'll have b plus 2a equal to 0. So there will be two situations, that b equal to 0 or b equal to minus 2a. You just see that. But b equal to 0 will not be a leads to a solution. So the case b equal to 0 does not leads to solution. So we'll not consider that case. The only case is b equal to. So on substituting b equal to 2a in equation 1. What was equation 1 is our complete integral. That is this. Let me write the complete integral here. So it is z minus ay minus x minus b whole square equal to 4b. Now we have substituted this value b equal to 2a here. That is z minus ay minus x minus 2a square is equal to 8bx minus 2a. So this will become plus and this will become minus. Now to obtain the envelope, we need to eliminate a from this. Here it is a. So what is our objective is now to eliminate a from this equation to obtain the envelope of this one. Let me call this as equation number 2 or 3, whatever the number is. 3 is number, I think. So to do this one, we need to differentiate this with respect to a. So on differentiating with respect to a, we get 2 times this whole quantity, that is z minus ay minus x plus 2y 2a into the derivative of this term, that is minus y plus 2 is equal to, on the other side we'll have minus 8a. Just see that 2 is get cancelled and left with 4. And if you simplify this one, we'll have the value of a actually. So that means this will gives me 2 minus y into z minus ay minus x plus 2a is equal to minus 4a. And this value we have here in this equation. So that value we can use. So z minus ay minus x plus 2a is equal to minus 4a upon 2 by y, 2 minus y. So using 3 we get, you see that it is square of this minus 4a upon 2y square is equal to minus 8ax. So what I did, I just substituted this value here. And if I take the square now, so that will leads to 16. A square is equal to minus 8ax into 2 minus y square. This will get cancelled. 1a is also get cancelled. We'll left with 2. So we'll have 2a is equal to this value, that is minus x 2 minus y whole square. So the value of a we get finally, that is minus x by 2, 2 minus y square. And if I substitute this value of a into the equation number 3, we obtain our required integral. The required integral that we have, it is this. Xy is equal to z into y minus 2, which is a required solution. So that's it for today. If you have any doubt, you can ask.